Welcome to this video on outliers and their effects. By the end of this video, you should be able to identify an outlier, describe the effect of an outlier, choose a measure of center, and a measure of variability based on whether or not a data set has an outlier. So an outlier is a data value that is much bigger or much smaller than the rest of the values. And they can have an effect on your mean and your median. So we're going to see what happens. So I have a data set here, and one of the numbers is much bigger than the rest of the numbers. You'll notice that 50 here is much bigger than the rest of the numbers. So we're going to say 50 is an outlier, and we will find out how to determine if a number actually is an outlier very soon. So the first thing we're going to do is we're going to put the data set in order least to greatest. So here we have them in order, and let's determine the mean with the outlier and without the outlier. We're going to find all these different measures. So let's go with the outlier first. So our mean with 50 is, if we add all of these up, use your calculator and add them all up, you'll get 162. And there are a total of 9 data values. 1, 2, 3, 4, 5, 6, 7, 8, 9. When I divide that down, I get a mean of 18. So mean with the outlier in place is 18. Now, I'm going to do the mean without the outlier, without 50. So when I add up all the numbers except for 50, these numbers, I get 112. But now, because I'm ignoring the 50, there's only 8 values there, so I'm going to divide it by 8, which will give me a mean of 14. So without the outlier, my mean is smaller. So what happens when there's an outlier, and in this case the outlier is on the right hand side, it was the bigger number, so that made our mean increase. So our mean went up 4 points with our outlier. Let's see what happens to the medians now. So the median with the outlier in place, there's the 9 values, which means we have an exact center. Right here is 15. That's if we have we are including the 50. So our median would be 15. So now let's look. If we take 50 off, we've got to look at this. Now we only have 8 values, so my new median would occur right there between 14 and 15, halfway between 14 and 15, which would be 14.5. All right, now the median changed, but do you notice how the median did not change a lot? Okay, with the outlier it was 15, without the outlier it was 14.5. So the median stayed about the same. It didn't change a whole lot, just a little bit. If we look at the modes, with 50 or without 50, 17 is the mode. It's the same either. It did not change. And then our range with the outlier is 50 minus 10, which is 40. The range without it is 17 minus 10, which is 7. So the range changed a lot. With the outlier, the range was much bigger with the outlier. So you can see outliers can affect these data values and what you're kind of looking at here. So which measure of center was most affected? Remember, measure of center is mean, median, mode. Well, our mean was the most affected. Okay, and then how was the range affected? The range was much bigger with the outlier. All right, so because of that, we want to use particular measures of center and variability depending on whether or not data has an outlier. So let's take a look. When determining your measure of center and variability, it's best to use the mean when there are no outliers. And we saw at this introduction up here that the mean was affected a lot more than the median was. So the median is a better measure of where the center of the data is when there are outliers. All right. Then the range. We had two kinds of ranges that we've talked about, just the overall range and the IQR. The overall range works well to describe how spread apart the data values are when there are no outliers. But the IQR is better to use to talk about the spreading out when there are outliers. Because really, the IQR is comprised of medians. We found Q1 and Q3 because they're using medians. So they're not greatly affected by outliers. Now, how do you know if a number actually is an outlier? Sometimes it can be hard to tell. So to do this, we have a rule. Any number that is less than Q1 minus 1.5 times the IQR would be called a lower end outlier. That would be on the left-hand side. And then any number that's greater than Q3 plus 1.5 the IQR is an upper end outlier. It'd be on the right-hand side. So this is a kind of a rule of thumb to help you determine, is that number an outlier? Because just because it looks like it's far away from all the other data values does not mean that it is. So let's take our data set here and let's put it in order. All right, so looking at this, you see our minimum is 2, our maximum is 16, but is 16 far enough away from the rest of the numbers to be considered an outlier? So we're going to use this rule, and it says Q1 minus 1.5 times the IQR and Q3 plus 1.5 IQR. We need to know what Q1 is, we need to know what Q3 is, we need to know what the IQR is. So we'll start with our median. So we have 1, 2, 3, 4, 5, 6, 7 data values. That means there's an exact center. And I just double checked, there's 3 numbers I haven't used on both sides, so I know I have the exact center. That's my median. Okay, to get Q1, it's the median of the lower half. It's an odd number, so there's an exact center. That's my Q1. And then my Q3 is my median of the upper half. It's an odd number of numbers, so there's an exact center, Q3. So now I know Q1, I know Q3, and because I know Q1 and Q3, I can find my IQR, because the IQR is Q3 minus Q1. So Q3 is 6 minus Q1, which is 3, so my IQR is 3. So now I'm going to plug this into these formulas, this rule up here, and we're going to see if the lowest number here is less than what we're about to get. So take Q1, which is 3, minus 1.5 times the IQR, which is also 3. And when we put that into our calculator, we get negative 1.5. Any number smaller than negative 1.5 in our data set would be considered an outlier. We don't have any numbers that low, so there's no lower end outliers. Okay, so that's on the lower end. Now we got to see if that's 16, because that's really the number we're curious about. So we're going to take Q3, which is 6, plus 1.5 times the IQR. And when I calculate that out, I got 10.5. Any number in the data greater than 10.5 is an outlier. So 16 is an outlier. Okay, so that's what you do when you're trying to determine if a value is an outlier or not. So let's try a couple of examples. All right, so here we are on our first example. I went ahead and put the data in order, least to greatest, and when I'm looking, the one number that kind of stands out is this 22. Really, we want to verify, do we think that's an outlier? We should always check both sides though. So we have 8 students, so that means that this is even, so there's no exact middle, which means we have to make the middle number. So that would happen after the 4th number. So our median is going to fall right there. Okay, that's our median. Halfway between 45 and 48. So let's add those two up and divide by 2. Which gave us a median of 46.5. We're not going to use that median, so it's not, we don't need it for a number, but it's nice to kind of see where it is. Now we need to find Q1 and Q3 so we can do some verifying. This is an even number of numbers, so it's going to happen between 2 numbers. That's my Q1. Halfway between 42 and 44 is 43, so Q1 is at 43, and Q3 is going to happen right there. Halfway between 50 and 54, which would be 52. So my Q3 is 52. Now, because I know my Q3 and my Q1, I can find my IQR, which is 52 minus 43, which is my IQR is 9. Now that we know what our IQR is, we're going to set up our equation using the rule to determine if there is an outlier. So I have Q1 minus 1.5 times the IQR of 9. So we're going to take our calculator and plug in 43 minus 1.5 times 9, and I'm going to get a value of 29.5. Any number less than 29.5 is an outlier. So that is less than 29.5. So 22 is an outlier. Now we're going to check on the other side. It doesn't look like there's going to be an outlier because these guys are fairly close together, but we're going to check. We're going to take Q3 plus 1.5 times the IQR. So Q3 is 52 plus 1.5 times 9, and that's going to give us 52 plus 1.5 times 9, 65.5, and we don't have any numbers greater than 65.5, so there's no outliers on the right hand side, just on the left. So we have to decide which measures of center and variability would work best for us. And so because we do have an outlier, we want to use the median instead of the mean, because the mean is greatly affected by an outlier. And for variability, we want to use IQR. All right, let's try this again. Pause the video and put these in order and come back when you're ready. All right, so here we are. We have everything in order. There are 6 data values, so that means we have to create the center value, and it will occur between the 3rd and 4th. So I'm going to draw a line there. If I add these 2 numbers together and divide by 2, we get 22.4, which really doesn't matter for what we're trying to figure out. But I'm going to just double check. I've got 1, 2, 3 numbers to the left and 1, 2, 3 numbers to the right. So I know I'm right in the center. So I need my quartiles, lower and upper. There's 3 numbers, which gives us an exact center, which is nice. So this is Q1. And on the upper side, there's 3 numbers, so there's an exact center, so that's my Q3. Now that I have Q3 and Q1, I can find out my IQR, which is going to be 24.8 minus 19.7. So 24.8 minus 9.7 is 5.1. That's my IQR. So we're going to check out our lower end first. I'm looking, these look pretty close together, and these guys look pretty close together. I don't think we're going to have any outliers, but we'll double check because you have to verify. So remember, we're doing Q1 minus 1.5 times the IQR. So Q1 is 19.7 minus 1.5, and with the IQR of 5.1. And when I put that into the calculator, I got a number that was 12.05. I do not have any numbers on the left lower than 12.05, so I have no outliers on the left. Let's go check on the right. So remember, this is Q3 plus 1.5 times the IQR. Our Q3 is 24.8 plus 1.5 times the IQR of 5.1. And when I put that into the calculator, I got 62. So none of our numbers go above 62. So we're set. We have 0 outliers. There's none. We proved it mathematically. So with no outliers, we want to use the mean to represent our center, and we want to use our range to represent our variability. All right, so let's try just a couple more here. So we have children on a playground, and we have their ages here. And we're going to see if there's any outliers, and then we'll go ahead and make a box and whisker plot for it and decide what measure of center and variability would be best. So let's go ahead and put these in order. Come back to the video once you're done. All right, so they're in order now. So there are 1, 2, 3, 4, 5, 6, 7 numbers. That means we have an exact middle for our median, which will happen right there at 4. And I'm just going to verify there's 3 numbers to the left and 3 numbers to the right, so I know I got the exact center. Now I need the Q1 and Q3. So Q1 is the median of the lower half. There's 3 numbers, so there's an exact middle. There's our Q1. There's our median. Q3 is the median of the upper half because there's an odd number of numbers. There's an exact middle. So that's Q3. So, and you can always double check. See how there's 1 number in each section? So we know we split it up evenly, so there's the same number of numbers each time. So our minimum is 2. Q1 is 3. Your median is 4. Q3 is 6. And your maximum is 11. Okay, so that's a little bit of a review. Now we're going to prove if there's any outliers using the same formula that we used previously. So it's going to be Q1 minus 1.5 times the IQR. Well, we haven't calculated the IQR yet, but it's Q3 minus Q1. So 6 minus 3 is 3. Okay. That gives us a low end value that's okay of negative 1.5. Well, you can't be negative 1.5 years old. We don't have any numbers less than negative 1.5, so we have no left end outliers. Let's go check the right end. So we have Q3 plus 1.5 times the IQR gives us 10.5. Well, 11 is past 10.5. It's greater than that, so that's going to make 11 is your outlier here. All right. Now, to make your box and whisker plot, we're going to go ahead and put it on a number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13, 14, 15, and 16. Our lowest number is 2. Our highest number is 11. Q1 is at 3. Your median is at 4. Q3 is at 6. I'm just reading the numbers from our 5-number summary. And then there's our box and whisker plot. Now you can see this right-hand tail is longer, much longer than the left-hand tail. So this is right skewed. In this case, it's skewed because there was an outlier on the right. It doesn't have to be an outlier that makes it right skewed, but in our case it was. And whenever you have a skewing like that, or you have an outlier, you want to use the median for the center and an IQR for the variability. All right, hopefully that answers any questions that you have. I'll see you in class.